Alright, let's go over this problem. So let's look at the figure. I have a triangle ABC. I notice it's 200 meters. I have one angle, 35 degrees. I notice I have a right triangle. I have an unknown length. What is the distance in meters between points B and point C? I have multiple choice. So the first thing I'm going to notice is the angle. This angle is going to tell me something, and I highlighted that's going to be my starting point. But before I get there, I notice that I have a length. I notice that I'm not given two sides of a right triangle. If I was given two sides of a right triangle, I can just use Pythagorean theorem. I can't use Pythagorean theorem because I don't have this side or this side. Does that make sense? Two sides, missing a third side. So because of that, I'm going to use trig. SOHCAHTOA. Now with my angle here, I'm going to go across and just label them. I have opposite. Class, this one is called the hypotenuse, cross, and then this one is the adjacent. Now I want you to think about that. I'm trying to solve for this one. We can call it line segment BC. I have the adjacent side, but I don't have the opposite side. So I don't need that. I don't need the opposite because there's no number there. There's no given length. Which means that I can cross up anything that has an O. I cross those two off because they have the opposite. And I only need something that has the adjacent and hypotenuse. Class that one with the letter C is called the cosine. So I have cosine of an angle. So I'm putting this blank here because you're actually putting an angle here. So that would be 35 degrees. Tomorrow's lessons we'll actually solve for angles based off of side lengths. The adjacent is 200. We'll put back the meters later. Over the hypotenuse, which is an unknown. I'll call that BC. So I have cosine of 35 equals 200 meters over BC. And then I can just use my math skills. I can make this a fraction. I have a proportion. I have a ratio and I have a ratio. Therefore, I have a proportion. A proportion is basically two fractions equal, and now I can just cross multiply. Now, if you did not cross multiply, BC times cosine of 35. Pay attention that the BC is in the denominator. So if you did something like divided both sides by 200 and said cosine of 35 divided by 200, which is right here, would have been incorrect. Because on the other side you have 1 over BC. So it's not this one. Okay, then I'm just going to solve for BC. So divide both sides by cosine of 35. 200 equals cosine of 35. That is the right answer. What happened? Let me show you what I was saying. Cosine of 35 equals 200. If I multiply by, divide both sides by 200, you're going to have cosine of 35 over 200 equals 1 over BC. And then to solve BC, you can take the reciprocal on both sides, and you'll get 200 over cosine of 35. That would work as well. So a second way of solving the problem. And the reason why I wanted to show you that is this. When you have the variable in the denominator, make sure that you're getting, the answer is that it's in the numerator. Does that make sense? So now I have a calculator ready equation. Let's just say we were asked to solve that. I notice this is in degrees, so I'm actually going to check my calculator. Always, always, always check. And then I can just type that in using extra parentheses. 200 divided by cosine 35. And if I ever had to round, I could say the distance is approximately 244, maybe round to the tenths, I don't know, 0.2 meters. And that's how you use trig to solve for the unknown.